Hey everybody, it's Miss Phoebus and I'm back with another lesson. This is lesson 50, step functions. These are a brand new type of function and we are going to learn how to graph them, how to read them and write their equations, and then we're going to go a little bit further and we're going to look at some examples of some real world step functions, kind of play around with domain and range a little bit. It's going to be pretty fun. So, our skills for today, I can identify the domain or range of a piecewise defined function, which we're going to get into that a little bit, but we're going to do a little bit more of the piecewise components tomorrow. And then I can graph step functions by hand and then show label key features of that graph. Here are our standards. We need to be able to graph functions and show key features, and in the kind of like the part B of that, step functions are there. So we have to be able to graph step functions and know different parts of the graph. So we are in the notes on page 240. Now, when we get to the real world examples, they won't be in the notes. I'd more like you to just kind of follow along. You don't have to take notes on those real world examples, but I'm going to be doing some graphing and talking about them. So I definitely want you to stick around, even though it's not in the notes. All right, so we have two different pictures here on the screen. We have a piecewise function on the left, and it might look a little scary, but you've been through enough of the components to where you can see, do you see how this part is quadratic? And do you see how this part is linear? And then this part's just a point. Right? So what we're doing is we're taking, or we're going to be able to take, any of our functions that we've already been graphing and kind of chop them up and glue them together so we can create a new function. And a lot of people go, Miss Phoebus, why are we even doing that? But the thing is that these are so real world. Yeah, they look weird, but they are, things change drastically suddenly and become very, very different in the real world from moment to moment. And so if we're going to graph things in the real world, we need to be able to change and go, okay, go from this to this to this, and be able to swap it up and make those changes. So how are you going to do that? Well, you should be able to take pieces of functions that you can graph and be able to stitch them together and create new graphs. So that's what a piecewise function is. So it's a single function which is made up of two or more different functions. Each equation is valid for some defined interval. So that means that over a certain span on the x-axis, be able to graph this, and at some point it stops and something new picks up. We're going to talk about that more tomorrow. But over here we have a step function, and step functions look like steps. Now, these look like steps you could actually climb, but you're not guaranteed that they're going to always be like that. They're always going to go up. They're always going to be equally spaced. They're always going to be the same length. You're not guaranteed that, but you are guaranteed that each piece that makes this step is nice and flat and horizontal. Now, if you notice, we have some closed circles at the beginning. You see that? See how they're filled in? And then I'm going to do this in a different color. At the end, you have some open circles. Okay? Now, some of you may be thinking back to what we talked about in Unit 2. Hey, Miss Phoebus, this is not a function because it doesn't pass the vertical line test. But it does because it passes through the closed circle. It hits the function once. But when it passes through an open circle, it doesn't hit that function. It gets, that piece is really close to that number, but not actually there. So it does pass the vertical line test. So a step function is a piecewise function, but every piece is a horizontal line segment, or it could be a point, but we're going to look at the horizontal line segments to actually build our steps. And it is a function. It passes the vertical line test. All right, so these equations look like monstrosities, and usually I have to break it down. I have to look at each part to make sure I understand what's going on. So let me break it down for you. Okay, yes, they are made up of lots of equations. there are 1, 2, 3, 4 steps in this function. Okay, so when I build my function, it's going to look like 4 steps. Now, those steps don't necessarily all have to go up or all have to go down. They could even jump around. But there are 4 steps because I see 4 lines in this function. So can you look at example 2 and see if you can figure out how many steps they're going to be in this function in example 2. So example 1 had 4 steps. Example 2 has 1, 2, 3 steps. So there are 3 steps in example 2. Okay, so that's the first part. So however many lines you have, that's how many steps you have. Now, there are, in each of those lines, there's some pieces that I want to look at. And I want to look at this piece first, right here. Okay, so usually you're given some sort of number, and this is really, remember f of x is just y. So this is y equals 1. Let me write this, y equals 1, y equals 3, y equals 5, y equals 7. All of those are horizontal equations. Remember Hoy and Vux? This is a whole bunch of Hoys, horizontal lines that have 0 slope and y equals in the equation. So instead of having to write all of these y equals, what we do, let's clean this up. What we do is we say, well, let's put them all together and we'll have 1 y equals in our equation. Okay, so instead of having to write it out with 4 different y equals, we kind of consolidated it into 1. Now this piece right here is just a grouping symbol. So it's not meant to be scary. It is just something that kind of holds it together and lets you know that they all go together. Okay, so nobody gets lost, anything like that. Okay, so we have 4 steps. We know the y values that they're supposed to be at. So then the next question is, what's going on with this if stuff? Okay, these are our intervals, the ifs. Now sometimes the ifs are written, but these are where that function is allowed to be. Okay, so it gives a starting point and a stopping point. So the first number is where does it start on the x-axis. Notice that all of these have x's in between. And where does it stop is the last number. Okay, so I start on the first line, I start at -5 and I stop at 0. And then I start at 0 and I stop at 5. And then I start at 5 and then I stop at 7. Now notice we have a lot of repeating numbers, right? 0, 0, 5, 5, 7, 7. Okay, so because of that, remember how I was showing you in that one picture, we had open circles and closed circles? Because we are sharing these numbers, we have to be very, very picky about what's going on with our circles. So if you notice, like this 0 has an open circle, this 0 has a closed circle. This 5 has an open circle, this 5 has a closed circle. Open circle, closed circle. And it usually follows a pattern like that, but it doesn't have to. So you have to learn how to read what's going on. Okay, so if you were in the classroom, we would be breaking out the highlighters and the markers. That's what we would be doing because color really, really works here. And so what I'm going to do is I'm going to cut the plane, and I'm going to use the green color to cut the plane. Now, when I cut the plane, I am doing it based off of these, and it's how I draw the function. What I'm about to draw on here in green is actually not the function itself. It's like guidelines to help me draw. So this is where the highlighter comes in. So what we're going to do is we're going to cut up the plane, and then we're going to go through and draw in the function. You can do this without the highlighter piece, but I'm telling you, at the beginning, the highlighting is very, very helpful. Okay, so what I want to do is I want to figure out where x equals -5. So 1, 2, 3, 4, -5 on the x-axis. I'm going to do a dashed line, but if you're using a highlighter, you can do like a bold, straight color, but all the way up and down, vertical line through x equals -5. Then I'm going to do another one at 0. So vertical line along, and that's where the color kind of comes in handy, because usually you can't see if you use a pencil, can't see what's going on that y-axis. All right, because I've already done this 0 is automatically done. So now I'm going to do a vertical line at 5. 1, 2, 3, 4, 5. Up, down. These are just vertical lines. Again, you can use a highlighter. 5's already done, so let's switch to 7. So 7's right here. And then the last one, we got that 7, the last one's 10. So 7, 8, 9, 10. So right through here. So what we're doing is we're creating this like almost like fences. We've got some boundary lines, and we're going to trap those graphs of each one inside these boundary lines. Okay, so what we're going to do now is we're going to do a little bit of labeling, and this is again not necessary, but it is something that is helpful. So I know between -5 and 0, I have a y value of 1. So I want to just write a 1 because that's the space between -5 and 0. All of it. All right, all of that is 1. And I'll go back and I'll graph that in a second. In the next space between 0 and 5, we're going to be graphing a 3. So all of this is where y equals 3. Between 5 and 7, we've got a y value of 5. And between 7 and 10, we have a y value of 7. So this is something to kind of help you visualize what's going on in there. Again, it's not necessary. It's actually not even the graph itself. It's just to get the pieces out of the equation and onto the graph to help you graph. All right, the next thing we're going to look at are the inequalities. Now, I know I'm going to be at a y value of 1 here. So on the left-hand side, I'm going to have a closed circle because that has an equal to bar. And on the right-hand side, I'm going to have an open circle because there is no equal to bar. So at -5, I'm going to have a closed circle at 1. And at 0, I'm going to have an open circle at 1 because we had a closed circle with the equal to bar first, and we had an open circle. Now notice that my red pieces of my function right now are on those boundary lines. And that's why those boundary lines are there. So it can show you where to start and where to stop. And then because I have my starting and my stopping place drawn, all I have to do is draw a horizontal line between the two of them. And that is the first step of my step function. All right, we're going to do the same thing, but now we're looking between 0 and 5, and I've got a closed circle at 0 because it has an equal to bar, and an open circle at 5. But my y value is now 3, so not at 1. So I'm going to go 0, 3, and put a closed circle there. And then I'm going to go to 5, 3, and put an open circle there. And then because I have my two endpoints, I'm going to just do a horizontal line between the 2 points. There's the second step of my function. Let's look at the third step. So I'm going to be between 5 and 7. I've got a closed circle at 5 and an open circle at 7. I have a y value of 5. So I'm going to go up to 5, 5, 1, 2, 3, 4, 5, and put a closed circle. I'm going to go to 7, 5, put an open circle, and then horizontal line in between. We got one more step, right? We had 4 steps. I've got 1, 2, 3 already drawn. I need the 4th step. So I'm going to have a closed circle at 7 and an open circle at 10. So it's 7, 7, 1, 2, 3, 4, 5, 6, 7. I have a closed circle, and then I have an open circle at 10. And I like that I know that they're horizontal pieces because it's easy to get my endpoint if I know where my starting point is. Now, if you look, as these are the x's and these are the y values, -5, 1 is a point on my graph. Let's see if I can get it in a different color. -5, 1 is a point on my graph. 0, 3 is a point on my graph. 5, 5 is a point on my graph. 7, 7 is a point on my graph. Okay? And then with my pieces that are open, I also have those points on the graph, but they have open circles. Okay? So these pieces right here, ones that are in red, but I'm covering over it in blue, this is the step function. The green is not the step function. The green helps you draw the step function. Okay, so that is your very first step function. How are you doing? It's a lot of information to process, I know. Okay, so we're going to do another one. And we've got 3 steps. We already know where they are. I'm going to grab my green for my highlighter so we can break up the plane. Can you tell, and these would be the questions I would be asking you in class, can you tell where we're going to draw the green dashed line for example 2? I'm going to be looking at this part. I'm going to be looking at this part, and that's going to help me figure out my green line, right? So I'm going to do a dashed line at 0, 3, 6, and 9. So 0 is here, x equals 0. There's one dashed line. X equals 3. There's another dashed line. X equals 6. There's another one. And x equals 9, right through there. Okay, so this is, again, this is the highlighter component. This helps you break up the graph and helps you know where to draw, where your start and your stop end. Not necessarily has to happen, but is a good guideline for you. All right, now, if you notice, all of these have closed circles on the left, open circles on the right. So I can follow that pattern a lot along as I go through and I graph. You're not guaranteed that though. You could have open circles on the left and closed circles on the right. You need to be able to read that. All right, so for my first function between 0 and 3, I'm going to have a y value of 0. Between 3 and 6, I'm going to have a y value of 6. Between 6 and 9, I'm going to have a y value of -3. Okay, so that just helps me know what my y values are. So I know that I start with a closed circle, end with an open circle. So I'm at 0. So 0, 0 is a closed circle. 3, 0 is an open circle, and connect it with a horizontal line. All right, now between 3 and 6, we're going to jump up to 6. So 3, 6, 1, 2, 3, 4, 5, 6, right there. There's a closed circle. And then 6, 6 is an open circle, horizontal line. And then between 6 and 9, I'm at -3. So this is like a weird staircase. You would not want this staircase at your house. We're going to be at -6, -3, closed circle. 9, -3, open circle, horizontal line. So 3 steps, we've got them there. And you're not guaranteed that they're all going to be the same length, that they're all going to be, you know, all going up. You have to be able to know what's going on in the situation, and you know that by looking at the equations. Be able to read each part. But you are guaranteed they're going to be flat horizontal lines. You are guaranteed that. All right, so here we go. Example 3. Now, here is our piece that we're going to be using our highlighter on. And if you notice, we have 2 that look similar to what we've been working with, between 2 and 4, between 5 and 7. Notice that those are going to all be open circles. And then you have this one where it's only one piece. So what this is going to do, we're looking at everything less than 1. This is going to go off to a negative infinity kind of idea. So it's going to be a step that goes forever. Okay, and that's all right. So can you tell how many steps we're going to have? There are going to be 3 steps. 3 steps because there are 3 equations. 1, 2, 3. All right. We're going to now do our horizontal. We're going to now do our vertical lines with our highlighter, or in my case, my green marker. Can you tell where I'm going to draw them? I'll clean this up a little bit. Okay, so I'm going to draw one of them, a vertical line at 1. And notice we don't have any repeats. So I'm going to also have one at 2. And then I have one at 4. I have one at 5. And then I have one at 7. 7. Now what we've done, because we're not sharing the same numbers like we did in the first 2 examples, where we had like it stops at 3 and then starts, the next one starts at 3. You don't have that sharing of that green line. We're going to have some gaps, and that's okay. We're allowed to have gaps in our function. So let's look at graphing this. So that means that where I'm looking at 1, everything less than 1 is going to be -2. There's a big giant space here that's going to hold -2. And then in between 2 and 4, that's here, I'm going to have 1. In between 5 and 7, I've got a y value of 4. So I'm going to have a really, really long step, a gap, a short step, a gap, and another short step. So let's look at graphing this. So I'm going to graph the -2. I'm starting with an open circle at 1, -2. And that, even though it looks like my endpoint, it's where I'm going to start. And it's going to go to the left because these are all the values less than 1. I'm going to put an arrow on it to indicate that it keeps going left and left forever. It's getting smaller and smaller, right, as it goes to the left. But it's going to keep doing that because we don't have a stopping point. There's no starting and stopping point. It's just a stopping point for this one. All right, we're going to jump over. We got a little bit of a gap. That's okay. Between 2 and 4, we have a y value of 1. So that means at 2, 1, I have an open circle. Remember, no equal to bar. And at 4, 1, we have another open circle. Again, no equal to bar. I think I did those a little high, but hopefully you get the point. And then just connect them with a horizontal line. All right, between 5 and 7, I'm going to be at 4. So 5, 4, 1, 2, 3, 4. Open circle because no equal to bar. At 7, 4, another open circle because there's no equal to bar. And then a nice flat horizontal line. And then we could erase the green lines, and then that would just be the step function. And there are 3 steps, right? We saw 3 equations. There are 3 steps. And we're done. All right, so let's look at example 4. How many steps are there? There are 4 steps, okay? I want you to pause the video, see if you can draw in the highlighter lines, and it might be one of those things where you don't want to commit to it, you don't feel 100% sure, so I'm just making this up. So let's say that would be one where I would highlight and just do the top. And then that way, if you're wrong and you got that highlighter, you can just come back through like with your pencil and you can put an X through it, but you have it committed to going all the way across the plane. Okay, so why don't you try to figure out where are we going to bust up this graph? Where would you draw, in my case, the green vertical lines? Okay, so you should have a vertical line at -5, right there here. because this right here is a -5. You should have a vertical line at -3. Because that's a -3. You should have a vertical line at 1. Because that's a 1. You should have a vertical line at 5. 1, 2, 3, 4, 5. Because that's a 5. And you should have a vertical line at 7. Because that's a 7. You don't need to draw those vertical lines. Woo, you're good. I have to draw them sometimes. All right, let's look. In between, oh, we have it where it's just less than -5. So here's -5. So here it's going to be 1 in this area, and it's going to go to the left forever. There's nothing in this next piece between -3 and -5 because there's no function written, so we're going to leave it blank. Between -3 and 1, we've got a piece that's a y value of 2. Between 1 and 5, yep, 1 and 5, we've got a y value of 3, and greater than 7. So we're going to skip the next little piece. It's going to be a gap, and we're going to have a 7. Oh, not a 7, a 4. So we're going to skip the next little piece, and then greater than 7 is going to be 4, and it's going to be here, and it's going to go to the right. So I'm just kind of planning these out as I go so that there are no surprises. So notice that I do have some open circles, but I also have some closed circles. So I have to pay attention to that. So my open circle for the first one is going to be at -5, 1, open circle. And because it's less than that, it's going to go left forever. There it is. All right. For the next one, I'm in between -3 and 1. I'm at a y value of 2. So that means -3, 2. It's going to be closed because there is a closed circle. And at 1, 2, there is an open circle because there was no equal to bar. And there is my horizontal line. Boop. All right, between 1 and 5, I'm going to have a y value of 3. So that means at 1, 3, I'm going to have a closed circle because that one has an equal to bar. At 5, 3, I'm going to have an open circle because, again, that one is just a less than. So no equal to bar. I'm going to draw that horizontal line. And then I skip the next part. There's nothing in there. At 7, 4, 1, 2, 3, 4, 5, 6, 7, I'm going to have a closed circle because it has an equal to bar, but I'm looking at everything greater than that, so I want to go to the right. Put an arrow on that end. Look at there, we got 4 steps, like we said, right? We do have a couple gaps, that's okay. And then we have these pieces that go off forever. And how do you know it goes off forever? Either to negative infinity or positive infinity. You don't have that compound inequality, that and compound inequality written for your x values. You don't have a start and a stop. You only have a single inequality. How are you doing? You doing okay? These take some time to wrap your brain around, so definitely practice. But if you are having questions, concerns, you're confused, join me in a Google Meet. If one's not open, email me so I can open one up for you, okay? Let's look at writing some some step functions. So we already have the graphs. What we're going to do is we're going to write them. And remember that we have some different pieces to worry about. So we are going to set this up with, you can either do f of x or y equals, right? This is an equation, so we want to have that. But remember, we're going to have pieces inside. So you can do a fancy bracket like that. It's not necessary. You can just not write it. That's okay too. But first we need to figure out how many equations we have in example 5. So can you count the pieces, the steps that we have? Now you may say 2, but I argue that there's 3. This little point right here is going to count as a step, and it's part of an equation itself. So what we're going to do is we're going to do blank, blank, blank. 3 blanks, and then some commas. I like the word if, but it's not necessary. But it allows us to know that we have our intervals. Remember those green lines? We have to write those as well. Okay, so what I want to do is I just want to figure out the y value. So, get rid of these. So for this piece right here, that's a y value of -1. For this piece right here, has a y value of 0. And then for this piece right here, it has a y value of 1. Okay, so I tried to color code that for you so you could see where those pieces come from. But that's the first thing that I would do. At the very least, get the y values in there. Now, it doesn't matter the order. I usually like to start from the bottom and go up, but the order doesn't matter. As long as you have each piece represented, and then you have each component, that has, its x intervals. Where does it start? Where does it stop? Okay. All right, so then let's look at the green piece. Let's ignore everything else and just look at the green piece. If I was going to look at the x values where this green piece was located, what's the smallest x value that this green piece is located? Isn't it headed to -infinity? It is. So from -infinity all the way up to, where does it stop on the x-axis? It stops at 0. Now, a lot of you would write between -infinity, you do this, and 0, right? There's an open circle here, so it wouldn't get an equal to bar. But I argue that that's too much, and we've talked about that before. It's too much. We don't need the -infinity. You just need the part where it's less than 0. So if x is less than 0, that's the part of the graph that we're going to draw or look at or whatever. Now we're going to switch to the orange one. I know we have the blue one next, but let's switch to the orange one. And a lot of you would say, well, it starts at 0 and it stops at infinity, so we should write 0 is less than x is less than infinity, which, okay, but that's too much. And usually we flip that around. We wouldn't say 0 is less than x, we would say x is greater than 0. And that's how you're going to see it written, like on the end of course. So I would recommend writing that where you write your x first, greater than 0. And I put greater than because it has an open circle. There's no equal to bar. Okay, so that takes care of the long pieces. The blue dot is something that it is a really, really tiny step. It's like so tiny, but it's there, right? So we've got to include it. Now notice that it's filled in, and there's only one dot, right? Not like a line that has a whole bunch of dots. It's one point. So that is where x equals 0. So anytime you have a point, it is where it is at that value. X equals 0. Okay? It comes up from time to time. But does it pass the vertical line test? What do you guys think? Would this pass the vertical line test? It does. It passes through those open circles like it doesn't even matter. Hits that point where x equals 0, passes through the other open circle, and it's like, hey, I only went through one point. I'm a function. I passed the vertical line test. Now, let's look at the domain and range, because we're going to talk about what's going on in domain and range in a couple other examples. So the domain, remember how far left, how far right? The domain, even though this is built up of 3 pieces, the domain is what we call continuous. So I start at -infinity, and I'm like, okay, and as soon as I get to this green open circle, then I bounce up here, as soon as I hit 0, and then as soon as I go beyond 0, I bounce up here to this open circle, and I keep going to the right. So there are no gaps, even though it looks like I've got 3 separate pieces in the domain, there are no gaps. There are no holes, so I go from negative infinity to positive infinity. Now that's not true. On some of the ones that we graphed earlier, we had gaps, and so we would have a break in the graph, we would have a break in the domain. Now, there is a break in the range. There are 3, because I'm only using one of 3 y values. I'm using -1, 0, and 1. So this is where we would write this discretely. -1, 0, and 1. Because we have a certain number of y values, we're not using everything between -1 and 1, because what's going on? Is there any y values here? Do you see any y values? I don't see any y values, so we can't say everything from -1 to 1, because we're not using all the y values. We're using 3 of them. So if we're only using 3 of them, we list them. We don't give a, hey, everything between here and here. Okay, so that's what's going on with the domain and the range. And if everything kind of lines up and gets used, then the domain is going to be from negative infinity to positive infinity. Now look at number 6. Does that go left and right forever? It doesn't, but when we talk about domain, we start this path. As soon as we get to that open circle, we jump. So there's not a break in the domain. There is a break in the range. Get to that open circle, jump. Open circle, jump. And then you stop right there. So we have a domain that is restricted, right? We aren't going left and right forever, and we will be able to talk about it. But it is something that the domains are all linked together, and so we can kind of glue them together in a bigger domain. Range, different story. But let's go back to writing the equation. We'll talk domain and range in a minute. So how many steps do we have? We have 4. So I'm going to do it this way, but remember, you don't have to have those bracket, curly brace. I'm going to do a comma. If, and then we got to get our interval in there. So there's lots of components to this, but they're all horizontal, so they're pretty straightforward. All right, so I like to start with the lowest one. It has a y value of 1. This one has a y value of 2, 3, and 4. Guess what? 1, 2, 3, and 4. If you want to mix them up because you feel like it, okay. Okay, so let's look at 1 just because it's first. There's nothing exceptional about any of these steps. So what we're going to do is we're going to start, and actually we could do this for all of them. We're going to start with x's in the middle, right? Because they have a starting point and a stopping point. So x has to be everything in between. So we're going to put an x in the middle. And then we're going to do, and if you notice, all of these have a closed circle on the left. So on the left of my x, I can do a less than or equal to. And then on the right, all of these have open circles. So on the right, I can just do a less than. Okay, so that just kind of gets you set up if everybody has a starting point and an ending point, then that can kind of just help you get set up. All right, so let's look at 1. The starting point, the furthest left it's going to go is -4 right there, -4. Remember, we're dealing with x's because we've already dealt with the y's. The y's are good. That's where our 1, 2, 3, 4 came from. So we're starting at -4 and we're stopping at -3. So it's a start and a stop. So then for number 2, we're going to start at -3, stop at -2. So -3 goes here, -2 goes here. So I like to think of them as starting and stopping points. I think it's helpful. All right, 3 starts at -2, stops at -1. So -2, -1. 4 starts at -1 and stops at 0. So -1 and 0. So those are our equations, including our intervals. How are you doing? You doing okay? All right, let's look at domain and range. So we already kind of talked about domain and range. We are not going left and right forever. So this is not negative infinity to positive infinity. But it is going to be the furthest left I go on the x-axis is -4, and it gets a bracket. Why does it get a bracket? That guy is a closed circle. The furthest right it goes is 0, but 0 has an open circle on it, so it gets a parenthesis. Now, yes, we are using everything in between because as soon as, like I was saying before, as soon as you hit that open circle and you get to that x value, in this case of -3, you hop up here. And then you go to that open circle, and as soon as you hit that x value -2, you hop up here. And so you're being pushed through on these steps, and there's overlap there to where you don't have to worry about breaking up that domain. Let's look at range. Now the range are the y values, the 4 y values that we use to write r. So it's discrete, it gets a curly brace. 1, 2, 3, 4. You cannot say from 1 to 4. That is a no-no. Can't do that. That's wrong. Because that implies you can use everything between 1 and 4. And again, there's nothing there, there's nothing here, there's nothing here. So we can't use everything. There are gaps in the range. So for step functions, the range is going to be discrete. You list each y value individually. For the domain, you can have breaks in the domain, but most of the time they overlap, and you can do a continuous domain. It just kind of depends on the situation that you're in. All right, let's look at a couple of real-world applications. Step functions are used widely in everyday life, especially in the world of business. Utilities like gas, electric, water are often billed according to a step function. This is also true for taxes and most fees. Best places to look for step functions is the post office. So here are first-class mail rates for packages from the U.S. Postal Service's website. And this may be old, but it still works. What is the domain and range of this function? So what we have to do in this case, I'm going to graph. These are not in your notes, so you can just watch, follow along. But you have anything from 1 ounce to 13 ounces. Once you hit 13 ounces, you have to leave first class mail and go to a different type of mailing system, priority mail. Okay, so you have to think about what are the possible weights that we could have. Now we have up to 13 ounces, so on my graph here, I'm going to have 1 ounce, 2, 3, I think I should be able to fit 13 on here. 8, 9, 10, 11, 12, oh, looky there, 13, this is number of ounces. And then I'm going to have to figure out price. So let's see, I need to be able to get up to $3. So I have figured out how I want to, I'm going to count by quarters, I guess. There's 0 down here. Okay, and I do have some space up at the top, but I'm happy with this. We are going to do a little bit of estimating, so it's not going to be super accurate. If I wanted it to be super accurate, I would count by something else. But I don't really want to count and put just the numbers up there because they are not evenly distributed numbers. You can't mail something that is 0 ounces because that means you're not mailing anything. But you might be mailing something that's very, very light, almost equivalent to 0 ounces. So what we're going to look is between 0 and 1. And I'm going to be charged $1.22. That almost right here is $1.25. So I'm going to have an open circle just below that line because I'm not going to really pay anything if I'm not shipping anything with 0, that has 0 weight. And then at 1, I'm going to put a closed circle. Now that means we have to determine kind of that starting stopping point. So if it says weight not over, so it's not over 1 ounce, it's 1 ounce exactly, I'm still paying $1.22. And that is going to be my first step. Let me look below that $1.25. All right, so then I'm going to have to go, well, what about 1.1 ounces? 1.2 ounces. Where does that fit in? So I'm going to look between 1 and 2, but I'm going to have an open circle at 1 for this next price. So that just beyond 1 ounce, so 1.005 ounces, would probably round us up to the next bracket. So we're going to be at $1.39. So that's going to be 25, probably about almost halfway. Again, remember, we're estimating. So we're going to have an open circle like right there and a closed circle right there. So that's between between 1 and 2 ounces. Slightly bigger than 1, but definitely at 2, we're paying $1.39. All right, 3, we're paying $1.56. That's really slightly bigger than 2 up to 3 ounces. So slightly bigger than 2, $1.56, so we're going to be like right above that. There we go. So you see my steps forming? All right, 4 ounces, we're going to be paying $1.73. So the next line up here is $1.75, so I'm going to be right below that. So I'm going to go between 3 and 4. And notice, because my open circle and my closed circle line up, it's still a function. Between 4 and 5, I'm at $1.90. I might have been able to do this without having to round or estimate. That's great. I'm going to go down a little bit. That's about $1.90. And then between 5 and 6, I'm at $2.07. So like that, maybe. Again, remember, we're estimating. Between 6 and 7, I'm at $2.24. Open circle here, close circle there. 7 to 8, we're at $2.41. I don't know, right about there, maybe ish. Between 8 and 9, we're at $2.58. Right, I don't know, right about there, maybe. Between 9 and 10, we're at $2.75. That's here to here. Between 10 and 11, that's $2.92. That's almost 3. Between 11 and 12, we're at $3.09. And between 12 and 13, we're at $3.26. So we've got an open circle. It's like right above. Okay, so there is my step function. Now it is it does pass the vertical line test, so it is a function. And I mean, this is what the Postal Service does. They go in and weigh it, and if it's within a certain weight, you get charged a certain price. And so they weigh it and they round you up. Just like if you were at 3.75 ounces, you don't get charged for 3, you get charged for 4 ounces. It rounds you up. Okay, so what is the domain and the range for this function? So the domain I want to talk about last. The range are all the y values. All of these guys, they're the range. So I'm looking at 1.22, and you write them as discrete functions. You do not say from here to here. So you're like, Miss Phoebus, why are you writing all of this out? Isn't that too much? Well, if I tried to write it shorter, it would be wrong. I don't want to get it wrong. I want to write each one out so that if I was working this problem, I would get the right answer because I'm supposed to list them out. It is not a span of values. It is each one individually. And that's going to be for our step function, always true. The domain, however, is different because we do have these overlapping pieces. Remember, the closed circle with the open circle on top of it allows us to continue on in our domain and have no breaks. So the furthest left we're going to go is 0. 0 gets a parenthesis because there's an open circle there. And the furthest right that we're going to go is 13. And 13 gets a bracket because there's a closed circle there. And I'm looking at everything between 0 and 13 ounces. That I am allowed to write simply and not list every single value because we can't list every single value. What if you've got a package that weighs 4.5 pounds, 4.55 pounds, 4.46 pounds, 4.92 pounds? You know, I mean, there's lots and lots of options. We would be here all day. Okay, so that's where we do the domain like that. If it's countable, yeah, it's a lot. It's 13. I wrote 13 numbers down, but guess what? That's not infinitely many. That's 13. I can write 13 numbers down. Okay, so for the range, you would have to list every individual y value. For the domain, you can list a range of values, span of values, that's a better way to say it, a span of values, so that you don't have to write each one individually. All right, here's another example. A wholesale t-shirt manufacturer charges the following prices for t-shirt orders. $20 per shirt for orders up to 20 shirts. So you can buy one shirt, two shirts, three shirts, all the way up to 20, and you would get charged $20. If you buy between 21 and 40 shirts, you would get charged $15. $10 for 41 to 80 shirts, $5 per shirt for anything over 80 shirts. So what is the domain and range of this function? So we're going to look at this one, and we're going to be looking at number of shirts here. We're going to look at price per shirt. You may want to think about, you could do something like total cost for the whole entire shipment, but we're just looking at price per shirt right now. Okay, we have to be able to, on our graph, get up to 80. So 10, 20, 30, 40, 50, 60, 70, there. 10, 30. You may be like, why are you still going? Well, I can go over 80 shirts, so why not? Now, my pricing, I'm only using 5, 10, 15, and 20, so I might want to space that out. So 5, 1, 2, 3, 2, 3. You're not going to be charged $20 for ordering 0 shirts. I mean, that doesn't make any sense because we haven't ordered anything. Why should we get charged? But do you see how we're counting by big numbers? So it's going to be hard to estimate, well, how much is one shirt going to be? Okay, so what we're going to do is we're going to still do 0, but we're going to do an open circle because we know at 0, you're not going to have any shirt orders that you have to pay for. So at 0 and 1 and 2 and 3 and 4 and 5 and 6, all the way up to 20, I'm going to be paying $20 a shirt. So I'm going to start with an open circle at 20, indicating that I can get really close but not actually be there. Now, we are in the domain going to be including, unfortunately, half a shirt and 3/4 of a shirt, okay? Just because we have to be able to graph this and not worry so much about the domain. So we would be looking at whole numbers between 0 and 20 is really what we would be looking for. So we're going to talk about that when we get to the domain. All right, so we're going to pay $20 for up to 20 shirts. Now, 20 shirts exactly, it sounds like we're going to be paying $20 per shirt still. But then when we get up to the next one, it's going to be 21 shirts. So we're going to do another like open circle there. So there's my horizontal line. Now, when I jump from 21 through 40, I'm going to do another open circle because it's not going to be 20 exactly, but what it does is it takes over for those numbers greater than 20. So then we're going to be at $15. So at 20, I'm going to have an open circle, 2015, and then I'm going to go to 40, just going right there, and in between there, we're paying $15 per shirt. And then 41, so I'm going to have an open circle there at 10, 40, 10, and they're going to 80 shirts. So this is a little bit longer of a step. What they're doing is they're trying to encourage you to buy more shirts, right? More shirts equals more business. And then $5 orders over 80 shirts. So I have an open circle there, and then it's just going to keep on going. Now, it could go on to 1 million. I don't know if that order would ever be a thing, but there might be very large orders, you know, a couple hundred shirts. It depends on what, you know, kind of organization is buying these shirts to maybe sell or give out to people or something like that. All right, so let's look at domain and range. The range is going to be easier than the domain, so let's go ahead and take care of that. The range are just all those Y values, 5 and 10 and 15 and 20. Remember, the order doesn't matter. Okay, and then for our domain, we're looking pretty much from 0 to infinity. So we're only going to have whole numbers, so we're going to say whole numbers only. Now, I think earlier I said something about integers, but integers include negative numbers, and we're not buying negative shirts. I don't know what that looks like. So whole numbers only. So we could, if we were going to do fancy mathematics, we could say x is an element of the whole numbers is W. Now, there is another example that I have. It'll probably be in the slideshow if you want to look at it. But it's about taxes, sales tax, does the same kind of thing. So it gets used a lot. You don't see the graphs very much, but they're there. So anytime they're like, well, between here and here, you're getting charged this price. And here to here, you're getting charged a different price. So that's a step function, and you could graph it. All right, we're going to wrap up that video. I will see you in a Google Meet if you got any questions about step function the rest of the semester. If you haven't watched my video on the rest of the semester, I need you to do that. Okay, I'll see you in the next video.